back. We are now doing part 3, which is actually deriving the equations for stress transformation. So let's start with this figure here. Let's say we have the stresses along these planes, the vertical and the horizontal, and we're planning to find the stress along the new axis, x dash, with the transformation angle of theta. Okay, so the first step is to actually remember that stresses, right, are nothing but force over area. So let's first transverse or transform our areas into the different angles. So let's assume the angle at this inclination of the new plane, theta, is delta A, okay, which is a small value of A. Which means if this is theta, let's highlight this, oops, if this is theta, again, that would mean that this side, which is the vertical side, is delta A cos theta, and the horizontal side is delta A sine theta. Okay, now what we want to do is force equilibrium. So we want to try to get the sum of forces along the x dash axis to be equal to 0. So to do that, uh, we multiply the stress by the area. So here we have sigma x, we multiply by delta A cos theta, which is what we got right here above, and then we have sigma y times delta A sine theta, and so on. So now we would like to equate these all forces equal to 0. So let's start. First we have sigma x dash delta A. That's the first force along the x dash. Then we have opposite to it. We have sigma x delta A cos theta, but we have to multiply by transformation angle cos theta. So now it's along this new plane, but that's opposite. So we're gonna have sigma x delta A cos theta. Now all of this is the force, and we transform the force by multiplying by cos theta. Now we have the force that's opposite to sigma x dash. Similarly with the shear, again the shear will be opposite, so it will be minus tau xy delta A cos theta, that is the force. To get this, we transform and we multiply by sine theta. So it's multiplied by sine theta. Again, from the bottom side, we have minus sigma y delta A sine theta, that's the force. And to convert this, we need to multiply by sine theta to get this component. Okay, so it's going to be minus sigma y delta A sine theta times sine theta. Again, we got another minus here for this tau, the shear, so it's going to be the force of the shear, tau delta A sine theta, times, to get this force we need to multiply by this angle cos theta, right? Because we would like to get this component. So times cos theta. That looks really messy. So let's try to simplify this a little bit more. Okay, so therefore I could say I have, now let's divide by delta A, because delta A now is kind of redundant, that's everywhere in all the components. So let's divide by delta A, and that goes to 0. So now we have sigma x dash, and let's take all the components to the other side of the equal so they get to be positive, nice and clean. So I have sigma x, and now we have cos theta times cos theta, so that's cos theta squared plus sigma y, and we have sine theta times sine theta, so that's going to be sine theta squared, and then we have plus, so if you notice we have tau xy cos theta times sine theta, and tau xy sine theta times cos theta, so they are equal. So let's just put 2 times tau xy cos theta sine theta. Okay, so the new stress equal to all stresses times their angles. Now we can simplify this a little bit more if you remember some trig relationships. So if you remember that 2 sine theta times cos theta is nothing but sine 2 theta. we can substitute this into this term. And if you remember that sine squared theta is 1 minus cos 2 theta on 2, and cos squared theta is 1 plus cos 2 theta on 2. Now if you use these trig functions, we can transform this equation into this. Where is my mouse? So okay, we're back. We have sigma x times 1 plus cos 2 theta on 2 plus sigma y times 1 minus cos 2 theta on 2 plus tau xy times sine 2 theta. Cool? Need a bit more space. Okay. And that is equal to our sigma x dash, or what we would like to call a sigma n, the normal stress. So let's simplify it a little bit more. We have sigma x plus sigma x on 2, sigma x cos 2 theta on 2 plus sigma y on 2 minus sigma y cos 2 theta on 2 plus tau xy sine 2 theta equal to sigma n. Now let's take so sigma x plus sigma y over 2, alright, plus sigma x minus sigma y on 2 cos 2 theta plus tau xy sine 2 theta equals sigma n. And this is our famous equation. This is what we use to transform stresses into different planes. Okay. Now we would like to derive the angle of transformation for the principal stresses. We would like to derive this formula. This term tan 2 theta equal to 2 tau xy on sigma y minus sigma x from the previous video. So this is the maximization of stresses, okay, in terms of angle. So we can think of this when we have a maximum angle for maximum point in a function. Okay, let me use a different color. Why am I stuck to red? Red, blue. Okay, so the slope at that angle, at that point, at a maximum point, would be equal to 0. So that is how we find the maximum, right? Which is dfx on dx equal to 0. Similarly, we can do the same here. So we can do that d sigma x dash on d theta, because we're trying to maximize the stress. That should be equal to 0. So we need basically to derive this term. Okay, and now we're getting some flashbacks from Math Modeling 1. Exciting. I'm not sure if you like math, but I do. Okay, so we have this term, tau xy sine 2 theta. So if we want to derive sine 2 theta, we would get 2 cos 2 theta. So we'd have 2 tau xy cos 2 theta. Okay, and that would be a constant in terms of angle. And here we have cos 2 theta, so that would be minus 2 sine 2 theta. So we have minus sigma x minus sigma y on 2 sine 2 theta. Okay, I'm running out of space again. Let's back down. Okay, and that is equal to 0. Okay, so now if we divide the whole term by sine 2 theta, so just divide by sine 2 theta, we should get 2 tau xy is tan 2 theta, okay, minus, let's just take this term all the way to the after equal, so nice and positive, and that would be equal to sigma x minus sigma y on 2, okay, times 2, right, times 2, and now the sine 2 theta is gone because we've divided by sine 2 theta. And now we noticed that we have similar terms on both sides. Now just 2 and 2 are gone. We can simplify in terms of angle. So I have tan 2 theta equal let me see,